So hi guys, today we'll be studying matrix multiplication. So matrix is one of the most powerful tools in mathematics, and today we'll study a part of it, which is matrix multiplication. Before going into matrix multiplication, we'll have to know what exactly a matrix is and where it is used. So matrix is basically a rectangular arrangement of numbers where you can arrange them into rows and columns, and anything like this is just a matrix. Anything. Just 1, 2, 3, 4. Yes, this is a matrix. Even if it's just a single row like 1, 2, 3, of course it's a matrix. It's sometimes even referred to as vector spaces, and these matrices come into use a lot of times in mathematics. So again, matrix multiplication. By multiplication, what do we get in our minds? Multiplication in arithmetic use is not same as matrix multiplication. In arithmetic use, 1 into 2 is 2, or we can even multiply 6 into 8, x into y. However, in matrix multiplication, we have certain conditions and they need to be fulfilled, only then we can multiply. We'll go into that deeper. First, before that, we should know matrix properly. So matrix like this, 1, 2, 3, 4, 5, 6, is a 2 into 3 matrix, which implies it has 2 rows and 3 columns. Now, 2 into 3 is sometimes called the order of the matrix. And okay, fine, we don't need to go deep into that. Again, now basically multiplication in matrix is completely different, and we need a condition, that is, so multiplication in matrix is, suppose we have a matrix A with number of rows m into n and columns, and we have another matrix B with number of rows p and number of columns q. They can be multiplied if and only if, let me write it down, n equals p. Only then we can do multiplication, and the resultant matrix, which is C, will have the order of m into q. This is how matrix is defined. Now I think you should be able to see the fact that A into B may not be equal to B into A. Of course. Now suppose we take the case of a matrix where it is A has 1 into 2 and B has 2 into 3. We can multiply A and B, and the resultant matrix will have a dimension of 1 into 3. However, if we multiply B into A, which means it's 2 into 3 and 1 into 2. 3 is not equal to 1, hence we cannot carry forward this operation, which implies matrix multiplication is not commutative. There are a few other properties like distribution, like A into B plus C gives us AB plus AC, and we have scalar multiplication, which is lambda times AB equals lambda A into B equals lambda of AB equals A times lambda of B. So when there's scalar multiplication, it follows like a dot product. The constant gets multiplied throughout the entries, all the elements. Suppose we have lambda times 1, 1, 1, 1, 1, 1, 1, 1, 1. We get it as lambda, 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 and so on. And now, so the basic condition is that the number of the columns of the first matrix should be equal to the number of rows of the second matrix. And multiplication, as I'm giving you an insight now, will also seem to be the same. So basically, summation k equals 1 to p a ik p kj equals c, which is a b from and of the type I into j. Now for let me ask you a question. Tell me if this is defined. Let me define A is equal to 2, 4, 6, 4, 7, 3, and then B as 2, 1, 8, 5. So now when we see, compare the rows and the columns. A is a 3 by 2 matrix, B is a 2 by 2 matrix. Yes, AB is defined. I'm done with the sheet. Let me move on to the next one. Now again, let us take an example. A into B, where both of them are 3 by 3 matrices. Let us take a general case where A is basically A1, A2, A3, B1, B2, B3, C1, C2, C3, and B is X1, Y1, Z1, X2, Y2, Z2, X3, Y3, Z3. So what is important here is that when we multiply A and B, the elements in the corresponding row get multiplied to the elements in the corresponding column of the second matrix. Let me write it down. So I'll cite down this example, A1, A2, A3 again. So this is our first row, this is our second row, this is our third row. So now what we do is we take our first row, and then we multiply it with the corresponding elements in the first column. So as we see, we keep on adding them like as if they were dot products. It is same as having a dot product of vectors A1, A2, A3 and X1, Y1, X1, X2, and X3. The dot product of these gives us A1x1 plus A2x2 plus A3x3. So this will serve as the first element in our C matrix, which is C equals A into B. Similarly, now if we multiply this vector and the second column, it gives us A1y1 plus A2y2 plus A3y3. Similarly, if we go on, it's A1z1 plus A2z2 plus A3z3. Now when we take this row, and we multiply it with the corresponding vector, which is x1, x2, x3, we get b1x1 plus b2x2 plus b3x3. Similarly, b1y1 plus b2y2 plus b3y3, b1z1 plus b2z2. This is basically a general case of any 3 by 3 multiplication of matrix. You can see I'm giving you the entire view of it. So yeah, on substituting the values, we can get the value for any matrix, like suppose it's 1 1 1 1 1 1 1 1 1, and then we are multiplying it with 1 0 0 0 1 0 0 0 1. This is called an identity matrix, by the way, just for your information. Identity matrix, and its determinant is equal to 1. So now when we multiply this, so we see here A1, A2, A3 are 1 1 1 respectively, B1, B2, B3 are again 1, C1, C2, C3 are 1. Now when we multiply them, we see we get 1, because 1 into 1 is 1, and then it's 0, so it cancels out this and this. And when we take this row and this column, we get 1 again. Again, everything cancels out to 0, and this again, so it is 1, just 1. So in this case, we get 1 again, because this and this, 1 into 0 is 0, 1 into 1 is 1, 1 into 0 is 0 again. when we multiply this, we get 0, 0 and 1, 1. So basically what we saw is, on multiplying these two matrices, we get this matrix. Now, if we substitute those values of A1, A2, A3, so yeah, now I'll take another small example, which is just a 2 by 2 matrix, which has 1, 6, 8, 9, and then here we have -2, 3, 4, 5. So here, since it's a 2 by 2 matrix, we don't have any issues of checking whether the number of rows and the columns of the second matrix is the same or not. So again, when we take this row and this column, we multiply it how we do. So it's -2 plus 24, and this one it's 3 plus 30, it's -16 plus 36, and it's 24 plus 45. This is our resultant matrix. So again, I would like to give you some other facts about matrices multiplication. Something like matrix multiplication is basically distributive, that is, I've already mentioned it. A into B plus C is equal to AB plus BC. It's not commutative, it may or may not be, but again, we take the case where it's not commutative. Matrix multiplication is associative, that is AB into C is A of B into C. So that's all about matrix multiplication, and I hope I was able to give you some insights about matrix multiplication. Thank you.